By the time you finish listening to this analysis, the object designated C2023A3 will have traveled more than 150,000 kilometers through the vacuum of space. And for every single one of those kilometers, its gossamer tail, a structure of ionized gas millions of miles long, will have continued to defy the fundamental laws of solar physics. Here is what we know for certain. It is currently brighter than 99% of all the stars you can see in the night sky. On a clear night, far from city lights, it is visible to the naked eye, a faint ethereal smudge against the velvet black. Officially, it is named Comet C. But buried within the data, pouring in from observatories around the world, is a conclusion that many are unwilling to say out loud. Its chemical signature, its impossible brightness, and the orientation of its ion tail are, according to multiple independent data sets, physically impossible. This isn't a matter of academic debate or a slight miscalculation in a predictive model. We are witnessing an object in our own solar system that behaves as if the rules of gravity and electromagnetism do not fully apply to it. What began as a routine astronomical discovery in early 2023 has escalated into a silent, global enigma. For months, the inconsistencies were dismissed as observational errors or transient phenomena. But as the object drew closer to Earth, its anomalies only intensified, becoming too persistent to ignore and too profound to easily explain. The story of this comet is not just one of orbital mechanics. It is a story of institutional contradiction, of convenient data glitches, and of a coordinated silence that seems to grow louder with each new impossible. Observation. Over the course of our investigation, we will methodically uncover the layers of this mystery. We will examine the timeline of its discovery and the precise moments when its behavior deviated from every known scientific model. We will dissect the spectrographic data that reveals a chemical composition so complex it should have been vaporized by solar radiation long ago. We will explore the physics of its tail, which appears to be actively resisting the constant million-mile-per-hour force of the solar wind. Let's begin with the basics, with what should be simple. A comet is, at its heart, a predictable object. We have studied them for centuries. They are often called dirty snowballs, agglomerations of ice, rock, and dust left over from the formation of the solar system, some 4.5 billion years ago. Their orbits are governed by the elegant and unwavering laws of Kepler and Newton. As they approach the sun, the ice on their surface turns directly into gas in a process called sublimation, creating a temporary atmosphere called a coma. This gas and the dust trapped within it are then pushed away by two distinct forces. The solar wind, a stream of charged particles flowing from the sun, pushes the ionized gas directly away from the sun, forming a straight, narrow ion tail. Solar radiation pressure pushes the heavier dust particles, which then lag behind in the comet's orbit, creating a curved, more diffuse dust tail. This is Cometary Physics 101. It is as fundamental to astronomy as gravity is to our everyday existence. Every single one of the thousands of comets we have observed has followed these rules. They are dependable, like cosmic clockwork. The angle of the ion tail relative to the Sun is a direct and measurable indicator of the direction and pressure of the solar wind at that exact point in space. It acts as a celestial weather vane, telling us about the invisible solar environment. But C2023, A3 is not behaving like clockwork. Its ion tail has been observed not once, but on multiple occasions by both professional and amateur astronomers, pointing at an angle that is significantly askew from the anti-solar direction. The deviation is not small. It is a stark, measurable discrepancy of up to 17 degrees. To put this in perspective, imagine holding a flag in a hurricane. You would expect the flag to be blown straight back, aligned perfectly with the direction of the wind. Now imagine the flag is stubbornly pointing 17 degrees to the side, as if held in place by some invisible force fighting the storm. That is what we are seeing with this comet's tail. The solar wind is the hurricane, and the tail is the flag that refuses to obey. The official explanations have been vague and insufficient, referencing transient solar wind pressure anomalies, or complex interactions with interplanetary magnetic fields. Yet simultaneous data from our sun-observing satellites, like the Solar and Heliospheric Observatory, or SOHO, show a stable, predictable solar wind during the periods of these anomalous observations. The data and the explanations are in direct conflict. This single anomaly would be enough to make Tsuchinshan Atlas one of the most mysterious comets ever recorded. But it is only the beginning. The second impossibility lies in its chemical makeup. Spectrographic analysis, which works by breaking down the light from the comet's coma into its constituent colors, allows us to identify the specific elements and molecules present. The analysis of Tsuchinshan Atlas, conducted at multiple observatories including the respected Lick Observatory in California, revealed spectral lines for complex hydrocarbons and crystalline silicates. These are molecules that should not be able to exist in their observed state so close to the Sun. The intense ultraviolet radiation should have broken them down into simpler, more stable components weeks ago. The mathematical probability of these compounds remaining intact under such conditions is, according to one paper that was quietly published and then largely ignored, less than 1 in 10 million. It suggests that either our foundational understanding of thermodynamics is incomplete, or something is actively shielding these molecules from their environment. Then there is the third anomaly, perhaps the most visually striking: its brightness. The core of a comet, its nucleus, is typically one of the darkest objects in the solar system. It's covered in a thick crust of dark organic material, giving it a reflectivity, or albedo, lower than that of asphalt. Yet the nucleus of Tsuchinshan Atlas is calculated to have an albedo approaching that of fresh snow. It is shining with an intensity that simple reflection of sunlight cannot account for. The energy output required to illuminate its massive coma to its current level is approximately 2.1 gigawatts, an amount of power that is profoundly inconsistent with a passive, inert object, simply shedding gas and dust. We are faced with three fundamental contradictions, each violating a different branch of physics. A tail that defies mechanics, a chemical signature that defies thermodynamics, and a brightness that defies the laws of optics and energy conservation. Any one of these would be a career-defining discovery for an astronomer. To find all three in a single object visible in our own sky is unprecedented. It is a mystery that has moved beyond the pages of scientific journals and is now unfolding, night after night, above our heads. The silence from the major space agencies about the confluence of these anomalies is becoming increasingly conspicuous. The question is no longer whether Comet Tsuchinshan Atlas is strange. The question is why it is strange and what its impossible behavior truly represents. To truly grasp the magnitude of the anomalies presented by Tsuchinshan Atlas, we must first build a foundation. We must understand the anatomy of a normal comet, an object that has been studied, modeled, and understood for centuries. These celestial wanderers are, for the most part, profoundly simple. They are relics, frozen time capsules from the birth of our solar system, orbiting in the vast, cold darkness of the Oort cloud, a theoretical sphere of icy bodies that surrounds our sun at a distance of up to a light year. For millions, sometimes billions of years, they drift in this cosmic deep freeze. But occasionally a gravitational nudge from a passing star or a galactic tide sends one of them tumbling inward toward the sun. This is the beginning of its transformation from a dark, inert ball of ice and rock into the spectacular object we recognize as a comet. The heart of the comet is its nucleus. This is the solid central body, typically only a few kilometers in diameter. It is not a smooth sphere, but an irregular, lumpy conglomerate of water ice, frozen gases like carbon dioxide and methane, and a significant amount of dust and rock. Think of it as a mountain of frozen mud and soot. As this nucleus ventures closer to the sun, its surface begins to warm. At a certain point, the ice doesn't melt into a liquid. In the vacuum of space, it sublimates, turning directly into gas. This process releases the dust that was trapped within the ice, and together, this gas and dust form a vast, glowing cloud around the nucleus called the coma. The coma can be enormous, often growing larger than the planet Jupiter, but it is incredibly tenuous, far less dense than the air in any vacuum chamber on Earth. And from this coma, two distinct tails are born, each shaped by a different force emanating from the sun. This distinction is critical. The first is the ion tail, sometimes called the gas tail. It is composed of the sublimated gas from the nucleus that has been ionized by the sun's ultraviolet radiation, meaning the atoms have been stripped of electrons, giving them an electrical charge. These charged particles are now susceptible to the solar wind. The solar wind is a constant stream of plasma, mostly protons and electrons, blowing outwards from the sun at speeds of around 400 kilometers per second. It exerts a pressure, a physical force. While this pressure is incredibly weak, around 1 to 6 nanopascals, which is billions of times weaker than Earth's atmospheric pressure, it is relentless. In the frictionless environment of space, this constant pressure is more than enough to push the lightweight ionized gas of the coma directly away from the sun. Always without exception, the ion tail points in the anti-solar direction. It is a cosmic windsock, a perfect unwavering indicator of the solar wind's path. The second tail is the dust tail. The particles of dust released from the nucleus are much heavier than the individual ions of gas. They are too massive to be significantly affected by the solar wind's pressure. Instead, they are pushed more gently by solar radiation pressure, the momentum of photons themselves. As these particles are released, they retain the orbital momentum of the parent comet. The result is a broader, more diffuse, and often gently curved tail that tends to follow along the comet's orbital path, lagging slightly behind the nucleus. You can think of it like the trail of smoke from a steam engine going around a bend. The smoke continues along the track's curve. These two tails, governed by two different forces, are the defining characteristic of a comet's appearance, and their behavior is as predictable as sunrise. Now let's examine the chemical makeup. Thanks to missions like the European Space Agency's Rosetta, which spent 2 years orbiting and even landing on Comet 67P/Churyumov-Gerasimenko, we have an incredibly detailed understanding of what comets are made of. Rosetta's instruments sniffed the coma and drilled into the nucleus. What did it find? Simplicity. The gas in Comet 67P's coma was overwhelmingly dominated by water, accounting for more than 60%, followed by carbon monoxide and carbon dioxide. It also found simple organic molecules like formaldehyde and hydrogen sulfide, but these were trace amounts. The chemistry was straightforward, precisely what you would expect from a primordial object that has been in a deep freeze for billions of years. Complex, heavy molecules are simply not expected to form or survive in such an environment. Finally, there is the matter of a comet's brightness. This, too, is a highly predictable variable. A comet's brightness, as seen from Earth, is a function of two main factors: its distance from the Sun and its distance from us. As it gets closer to the Sun, it heats up. Its rate of outgassing increases dramatically. The coma expands, and it reflects more sunlight, appearing brighter. Astronomers have developed sophisticated models that can predict a comet's light curve, its brightness over time, with remarkable accuracy. These models account for the comet's size, its composition, and its orbital path. Any significant deviation from this predicted brightness is a major red flag for astronomers. Such deviations are rare, and when they do occur, they usually signal a catastrophic event. For example, a sudden massive surge in brightness might indicate that the nucleus has fractured under thermal stress, exposing a huge new surface area of fresh ice to the sun, causing a massive outburst of gas and dust. But these outbursts are typically short-lived, and the comet's brightness soon fades back to its predicted level, or even lower if the fragmentation was severe. A sustained, impossibly high brightness that doesn't correspond to such a destructive event is something else entirely. So this is our baseline. This is a normal comet, a nucleus of simple ice and rock, darker than coal. A coma of simple, expected gases, two tails, one of gas pointing directly away from the sun, and one of dust following its orbit. And a predictable brightness that waxes and wanes according to the unchangeable laws of orbital mechanics and thermodynamics. It is a system built on elegant, understandable, and verifiable physics. It is this very predictability, this clockwork certainty established over centuries of observation, that makes the sustained, multifaceted anomalies of Comet Tsuchinshan Atlas so profoundly unsettling. It is not just deviating from the model, it is behaving as if it is operating under a completely different set of rules. Every investigation begins with a timeline. By placing events in chronological order, we can begin to see patterns, contradictions, and moments where the official narrative begins to fracture. The story of Comet Tsuchinshan Atlas is no different. It began not with a bang, but with a faint, unassuming flicker of light on a digital sensor. The date was January 9th, 2023. At the Purple Mountain Observatory, also known as Tsuchinshan in eastern China, astronomers were conducting a routine sky survey. An automated telescope captured a series of images showing a very faint, slow-moving object. It was barely distinguishable from the thousands of asteroids catalogued each year. A month later, on February 22nd, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in South Africa, independently recorded the same object. The observations were combined, an orbit was calculated, and the object was officially designated C2023A3 Tsuchinshan Atlas. The C indicated it was a long-period comet, meaning its orbital period is greater than 200 years. In this case, its orbit was calculated to be a staggering 26,000 years long. This meant it was a visitor from the deepest, coldest reaches of the Oort cloud, a pristine sample of the primordial solar system on its first journey into the inner planets. For the next 18 months, everything proceeded as expected. The comet followed its predicted path with textbook precision. Astronomers tracked it, amateur enthusiasts occasionally imaged it, and all the models agreed. It would likely become a moderately bright object, perhaps reaching a magnitude visible with binoculars, but nothing spectacular. It was just another of the dozen or so comets discovered each year. The first hint that something was unusual came in late August 2024. As the comet approached its perihelion, its closest point to the Sun, it began to brighten faster than any model predicted. This wasn't unheard of. Some comets have pockets of volatile ices that can cause minor outbursts. The astronomical community noted the deviation, adjusted their models, and continued to watch. The real alarm bell, the one that no one could ignore, rang on September 28, 2024. In a period of just 24 hours, the comet's brightness surged by a factor of 400%. An increase of this magnitude is not an outburst. It is an explosion. It catapulted the comet from a dim binocular object to one easily visible to the naked eye, making it brighter than most stars in the constellation Leo, through which it was passing. The official explanation, quickly disseminated by major astronomical clearinghouses, was forward scattering of light. This is a known phenomenon where, for a brief period, the dust particles in a comet's tail are aligned in such a way that they reflect sunlight directly towards the observer, causing a temporary surge in brightness. It's like catching the glint of the sun off a distant car window. The explanation made sense on paper, but there were two problems. First, the effect is typically short-lived, lasting a few hours at most. The comet's brightness surge, however, did not subside. It remained at this impossibly high level for days, then weeks. Second, forward scattering primarily affects the dust tail, not the core brightness of the coma itself, which was also shining with unprecedented intensity. The explanation was convenient, but it didn't fit all the facts. While the professional world was debating the brightness, amateur astrophotographers, the dedicated citizen scientists with powerful backyard telescopes, noticed something far stranger. On the night of October 2nd, 2024, images began to appear on astronomy forums from observers in Europe and North America. These weren't blurry snapshots. They were long exposure photographs taken with sophisticated equipment. And they all showed the same impossible thing. The comet's bright, narrow ion tail was not pointing directly away from the sun. The photographers, many of whom have decades of experience, calculated the discrepancy. It was off by a staggering 17 degrees. This was not a subtle deviation. It was a clear, unambiguous violation of cometary physics. For 48 agonizing hours, the major agencies remained silent. The forums were alive with debate. Some suggested it was an imaging artifact, a distortion caused by equipment or software. But as dozens of images from different people, using different telescopes and cameras, all from different locations, flooded in showing the exact same anomaly, that explanation became untenable. Finally, on October 4th, a brief statement acknowledged the observation. It was attributed to a localized solar wind pressure anomaly. But as we've noted, data from solar observatories like SOHO and Stereo A showed no such anomaly. The solar wind was stable. The contradiction was stark and absolute. This created a schism. On one side, you had the official explanation, which required believing in a solar wind event that our dedicated solar observatory somehow missed. On the other, you had the photographic evidence, which suggested the comet itself was generating a force capable of resisting the sun's constant pressure. The timeline reveals a pattern of behavior that is deeply troubling. A discovery followed by a period of normalcy. Then, an anomaly appears. The anomaly is first reported not by official channels but by the amateur community. There is a period of institutional silence, a delay. Then, an official explanation is offered that is technically plausible in isolation, but is directly contradicted by other available data. This pattern would repeat. The unusual chemical signatures revealed by spectroscopy were initially dismissed as noisy data. The sustained brightness of the nucleus was attributed to unusual outgassing geometry. Each anomaly was treated as a separate, isolated problem to be explained away. But the timeline forces us to see them as they are. A connected series of physically impossible behaviors, observed over a period of weeks, accompanied by a consistent pattern of institutional denial and deflection. The contradictions are not in the comet. They are in the story we are being told about it. Beyond the visual strangeness of its tail and the perplexing intensity of its light, a deeper, more profound anomaly lies hidden within the very substance of Comet C Atlas. This evidence isn't found in photographs, but in the subtle language of light itself, decoded through a process called spectroscopy. When light from a celestial object is passed through a prism-like instrument called a spectrograph, it is spread out into its constituent colors, a rainbow. But this rainbow is not continuous. It is crossed by a series of dark or bright lines, a unique barcode that reveals the precise chemical elements and molecules present in the light source. It is the bedrock of astrophysics, allowing us to know what distant stars are made of without ever visiting them. In early October 2024, as the comet's other anomalies were becoming undeniable, the 36-inch Shane telescope at the Lick Observatory, perched high on Mount Hamilton in California, was turned towards the object. Its powerful cast double spectrograph began to collect photons, painstakingly building up a chemical profile of the comet's coma. The initial results were so unexpected that the observing team reportedly ran diagnostic checks on their equipment, believing the instrument itself had to be malfunctioning. It wasn't. The data was real, and it was impossible. The spectrographs showed the expected signatures of simple molecules: water, carbon monoxide, the hydroxyl radical. But superimposed on this familiar background were strong, clear spectral lines corresponding to complex silicate structures and long-chain hydrocarbons. To be clear, finding silicates, the building blocks of rock, in a comet is normal. They make up the dust. But these were not simple amorphous dust grains. The spectral signature indicated crystalline silicates, minerals like forsterite, which can only form at extremely high temperatures, over 1,000 degrees Celsius. Finding these in a frozen comet is like finding a perfectly baked brick inside an ice cube. Furthermore, the hydrocarbons detected were not the simple methane or ethane one might expect. They were polycyclic aromatic hydrocarbons, or PAHs, complex molecules with intricate ring-like structures. These are the building blocks for some of the most complex organic chemistry in the universe. Here is the central problem. At the comet's distance from the Sun during these observations, its surface temperature was well over 400 Kelvin, or about 127 degrees Celsius. In the harsh, unfiltered glare of solar radiation, particularly the high-energy ultraviolet photons, these complex molecules should have been destroyed within hours. The process is called photodissociation. The UV photons act like tiny molecular sledgehammers, shattering the delicate bonds that hold these large molecules together, breaking them down into simpler, more stable fragments. The survival of these complex structures in the coma is a direct violation of established photochemistry. Some researchers, attempting to find a natural explanation, propose that perhaps the molecules were being freshly released from the nucleus, shielded deep within the ice until the very last moment. But this doesn't solve the problem. The spectral lines were detected far out in the coma, tens of thousands of kilometers from the nucleus, where they would have been exposed to the full force of solar radiation for many hours, if not days. Let's quantify this impossibility. A detailed analysis, published in a preprint server and still awaiting peer review, calculated the survival rate of these specific PAHs in the solar environment at the comet's orbital position. The conclusion was stark. The mathematical improbability of these compounds remaining stable for the duration required to travel from the nucleus to their observed position in the coma is less than 1 in 10 million. This isn't a small discrepancy, it's a statistical miracle. It implies one of two things. Either our century-old understanding of how ultraviolet light interacts with molecules is fundamentally wrong, or something unseen is actively protecting these complex molecules. A shield. To put this chemical anomaly in its proper context, let's compare it to the data we have from another well-studied comet. In 2004, NASA's Stardust mission performed a daring feat of celestial engineering. It flew through the coma of Comet Wild 2 and used a collector filled with a substance called aerogel to capture dust and gas particles. This sample was then returned to Earth for analysis in laboratories around the world. The Stardust mission was a resounding success, giving us our first direct sample of a comet. The analysis found a treasure trove of simple organic molecules confirming our models. But it found nothing approaching the complexity or the crystalline structure of the silicates being consistently detected in the spectrum of Tsuchinshan Atlas. The chemistry of this new object is orders of magnitude more complex, more evolved than anything we have ever sampled directly. It is as if we expected to find simple huts and instead found a skyscraper. The implications are profound. The high-temperature crystalline silicates suggest they were formed in the hot inner region of a solar system, close to a star, before somehow being ejected and incorporated into an icy body in the cold outer regions. This is a known but rare process. However, the presence of the fragile, complex organic molecules alongside them is a glaring contradiction. The very conditions needed to create the crystals would have obliterated the organics. They cannot naturally coexist in a pristine primordial object. This isn't just a puzzle, it's a paradox written in the language of chemistry. The comet's coma is not just a cloud of gas and dust. It is a repository of molecules that should not be there, that cannot survive there, and yet, demonstrably, are there. This impossible chemistry points to a process that is not accounted for in any current model of cometary science. It suggests that the coma is not a simple, passive cloud of sublimating gas, but a protected, shielded environment where the laws of photodissociation are somehow being held in abeyance. In the silent, sun-drenched emptiness of space, there are few things darker than the nucleus of a comet. These celestial wanderers are coated in a thick mantle of tar-like organic compounds, a residue left behind after eons of cosmic ray bombardment. This dark crust makes them notoriously difficult to see. Their reflectivity, a measure known as albedo, is incredibly low. For a typical comet, the albedo is around 0.04. To put this in perspective, fresh asphalt on a new road has an albedo of about 0.05. A comet's nucleus is quite literally darker than asphalt. It absorbs 96% of the sunlight that strikes it, reflecting a mere 4%. This is a fundamental, well-documented characteristic of nearly every comet we have ever studied. We expect them to be dark. It is against this backdrop of profound blackness that the nucleus of Comet Tsuchinshan Atlas presents its next and perhaps most glaring impossibility. It shines far, far too brightly. By carefully measuring the total light coming from the comet, and then subtracting the light reflected by the gas and dust in its coma, astronomers can calculate the brightness of the nucleus itself. The process is complex, involving sophisticated modeling of gas dynamics and light scattering, but it is a standard technique. When this technique was applied to Tsuchinshan Atlas, the results were nonsensical. The calculated albedo of its nucleus was not 0.04. It was 0.6. An albedo of 0.6 is not just bright, it is brilliantly reflective. It is comparable to the albedo of freshly fallen snow or the pristine ice caps of Mars. If Tsuchinshan Atlas's nucleus were a typical comet, its surface would have to be composed almost entirely of clean, unblemished water ice, with none of the dark, insulating crust that is the hallmark of every other long-period comet. This in itself is a deep puzzle. Where is the dark, carbonaceous mantle that should have formed over billions of years in the Oort cloud? Why does this particular object appear as if its surface has been freshly resurfaced with brilliant ice? But the mystery deepens, because even this impossibly high reflectivity is not enough to explain the total energy output we are observing. The sustained brightness of the comet's vast coma cannot be accounted for by reflected sunlight alone, even from a nucleus made of perfect mirrors. The math simply doesn't work. The energy required to illuminate the coma to its observed level, a phenomenon known as exciting the gas molecules until they glow, is approximately 2.1 gigawatts. That is 2.1 billion watts. This is roughly the power output of a large nuclear power plant on Earth. For a passive object, a simple, dirty snowball, to be triggering this level of luminous energy through mere interaction with sunlight is a physical contradiction. Something else is contributing to the energy budget. Something is actively powering the glow. This is not mere speculation. It is a conclusion supported by data from an entirely different part of the electromagnetic spectrum. NASA's Near-Earth Object Wide Field Infrared Survey Explorer, or NEOWISE, is a space telescope that views the cosmos in infrared light. It is specifically designed to hunt for asteroids and comets by detecting the heat they radiate. When NEOWISE was tasked to observe Suchenshan Atlas, its thermal readings returned another piece of confounding data. The infrared signature did not match the profile of any known cometary composition. A normal comet's heat signature is straightforward. The side facing the sun is warm, and the side facing away is incredibly cold. The heat radiates in a predictable, passive way. The NEOWISE data for Suchenshan Atlas, however, showed a thermal profile that was more uniform, as if the object were being heated from within. It suggests a thermal signature from a non-passive or endothermic source. There appears to be an internal heat engine that is warming the nucleus to a greater degree than can be explained by solar radiation alone. This internal heat would help explain the explosive and sustained outgassing that contributes to the comet's high brightness. But it opens up an even more profound question. What could possibly be generating that much heat inside a small, icy body in the middle of space? Natural explanations are difficult to come by. The decay of radioactive elements, a source of heat within planets like Earth, is insufficient by several orders of magnitude for an object this small. Chemical reactions within the nucleus, such as the crystallization of amorphous ice, can produce bursts of heat, but not a steady, sustained output of this magnitude. We are left with a nucleus that is a series of contradictions. It is as reflective as snow, when it should be as dark as coal. It is radiating more energy than it receives from the sun, and it appears to have its own internal heat source. One astronomer, speaking on the condition of anonymity to a respected science journal, summarized the problem succinctly. The object's energy budget doesn't balance. You can't get that much light and heat out of it without putting a massive amount of energy into it. Solar input isn't enough. We are missing the primary term in the equation. This missing energy, this X factor, is at the heart of the mystery. The nucleus is not behaving like a dead, passive lump of ice and rock. it is behaving like an active, powered system. The light we see with our own eyes is not just reflected sunlight. The data strongly suggests that it is, at least in part, generated light, powered by an unknown internal mechanism that is producing gigawatts of energy. This isn't a comet, it's a beacon. Of all the anomalies exhibited by Comet C, the behavior of its ion tail is perhaps the most visually arresting and scientifically indefensible. It is a spectacle written in glowing gas across millions of kilometers of space, a direct observational defiance of fundamental physics. As we have established, the solar wind is a relentless force. It flows radially outward from the sun in all directions, a constant hurricane of charged particles. An ion tail, being composed of charged particles itself, has no choice but to be swept along by this current. It must point directly away from the sun. Any deviation from this anti-solar direction would require a secondary force, a force powerful enough to counteract the immense pressure of the solar wind. For a small inert comet, no such natural force is known to exist. Yet, on at least 3 separate and well-documented nights, the ion tail of Suchinshan Atlas was observed pointing somewhere else. The first widely reported observation was on October 2nd, 2024. Amateur astrophotographers and professional observatories alike recorded a deviation of approximately 17 degrees from the expected anti-solar vector. The second event occurred 5 days later, on October 7th. This time the deviation was smaller, around 11 degrees, but it was sustained for several hours. The third confirmed observation was on October 11th, with a measured angle of 15 degrees. These were not fleeting moments. They were sustained periods where the entire, multi-million kilometer-long structure of the ion tail was held at a fixed, impossible angle, like a rigid rod resisting a current. To verify the conditions in space at the time of these events, we can turn to our sentinels that constantly monitor the sun. NASA's Stereo A spacecraft, the Solar Terrestrial Relations Observatory ahead, is in a unique solar orbit that allows it to monitor the solar wind upstream from Earth. Its data is unambiguous. On October 2nd, 7th, and 11th, the solar wind vector it recorded was stable, uniform, and precisely aligned with the expected direction. There were no gusts, no transient pressure anomalies, no magnetic turbulence that could account for the comet's behavior. The hurricane was blowing straight, but the flag was pointing sideways. This leaves us with a stark and unavoidable conclusion. The force causing the deviation must be originating from the comet itself. So, what kind of force could achieve such a feat? The ion tail is a plasma, a gas of charged particles. The only force that can exert significant influence over a plasma, other than a direct collision, is electromagnetism. For the comet to deflect its own ion tail, it would need to generate its own localized, powerful magnetic field. It would have to create a magnetosphere, a magnetic bubble around itself that could interact with the tail plasma and the solar wind in a controlled way. The physics of this interaction are well understood. We see it in the way Earth's magnetic field protects us from the solar wind, creating the auroras. But the scale is monumentally different. For a comet to generate a magnetic field strong enough to produce the observed 17-degree deflection of its ion tail against a typical solar wind, it would require a field strength of at least 500 nanoteslas at the point of interaction. For comparison, the magnetic field of the planet Jupiter, a gas giant with a molten metallic hydrogen core, is about 400,000 nanoteslas at its cloud tops. Earth's field is around 30,000 nanoteslas. The idea of a tiny frozen comet nucleus generating a field of 500 nanoteslas is, from the perspective of planetary science, absurd. Planetary magnetic fields are generated by a process known as a dynamo. This requires three things: a conductive fluid interior, like Earth's molten iron core, rapid rotation to create Coriolis forces, and a source of heat to drive convection currents within the fluid. A comet nucleus has none of these things. It is a small, solid, slowly rotating ball of frozen, non-conductive ice and rock. It is physically incapable of producing a dynamo. It has no internal mechanism to generate a magnetic field of any significant strength. The official explanations from the few agencies willing to comment have been conspicuously inadequate. As mentioned, the idea of a transient solar wind pressure anomaly was floated, but this is directly contradicted by spacecraft data. Another suggestion was that the comet might be interacting with a localized fold in the interplanetary magnetic field, a complex structure known as a heliospheric current sheet crossing. While these crossings do exist, they are vast, diffuse structures, and their magnetic field strength is typically only around 5 nanoteslas, 100 times too weak to cause the observed deflection. Furthermore, such an interaction would be a fleeting event, lasting minutes, not the hours over which the anomaly was observed. Each natural explanation that has been proposed fails when confronted with the actual numbers and the supporting data from our own instruments. The data from the solar observatories and the data from the comet watchers are in direct conflict, and the official explanations attempt to obscure this fact by citing phenomena that are either not happening or are far too weak to be the cause. We are forced to consider the evidence on its own terms. We are observing an object that is behaving as if it has an internal, controllable magnetic field generator. A field powerful enough to sculpt and steer its own plasma tail, resisting the force of the sun itself. This is not the behavior of a natural comet. A comet is passive. It is a victim of its environment, shaped by the sun's energy. Tsuchinshan Atlas is not passive. It appears to be an active agent, controlling its own plasma environment in a way that defies our understanding of what a comet is. The tail that points the wrong way is not just a curiosity, it is a declaration. It is a signal that the object at its head is not a simple snowball, but something far more complex, something with an internal power source and the ability to project a powerful, invisible force into the space around it. In the face of an unfolding scientific anomaly of this magnitude, one would expect a flurry of activity from the world's leading space agencies. Urgent press conferences, releases of high-resolution imagery, and collaborative research papers from international teams would seem the natural response. Instead, the defining characteristic of the institutional response to Comet C Atlas has been a confusing, contradictory, and ultimately deafening silence. Let's dissect the timeline of official statements, because it is here that the pattern of obfuscation becomes clearest. In the first few days of October 2024, as the evidence for the tail deviation and impossible brightness became overwhelming, the primary response was simply no response. Queries to the press offices of major space agencies were met with boilerplate replies. The data is being analyzed, or we cannot comment on unverified observations. This initial stonewalling created an information vacuum, which was quickly filled by the remarkable work of amateur astronomers and independent analysts. It was they who first confirmed and quantified the anomalies. Only when the evidence became too widespread to ignore did the first official explanations begin to trickle out. NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, is the world's premier center for robotic space exploration and orbital mechanics. Their public statement on October 5th was a masterclass in institutional deflection. They stated that the reported anomalies in both the tail's orientation and the nucleus's brightness were likely observational artifacts caused by atmospheric distortion and complex light scattering effects. In essence, they were suggesting that the thousands of observations from around the world were not real, but were instead optical illusions created by Earth's own atmosphere. This explanation was immediately problematic. Many of the most compelling photographs and spectrographic readings were taken from high-altitude observatories, specifically chosen for their locations above the thickest, most turbulent layers of the atmosphere. The explanation simply did not hold water, but it served a purpose. It cast doubt on the data and provided a plausible-sounding dismissal for the media and the general public. The narrative, however, was about to be directly contradicted by another equally respected institution. Just 2 days later, on October 7th, the European Southern Observatory, ESO, operating the Very Large Telescope in the pristine skies of the Atacama Desert in Chile, released a raw data set. This wasn't a press release. It was the unprocessed spectral and positional data from their own observations. Crucially, this data was captured from one of the best observing sites on the planet, almost entirely free of the atmospheric distortion JPL had cited. The ESO data confirmed the anomalies in excruciating detail. It showed the 17-degree tail deviation and the spectral lines for the impossible complex molecules. The data was a bombshell, a direct institutional contradiction of the official American narrative. For a brief period, it seemed like a genuine scientific debate was about to begin. Then, something unprecedented happened. Less than 24 hours after its release, the ESO dataset was retracted. The webpage was taken down, replaced by a terse notice citing the need to correct for significant calibration errors. The data they claimed was unreliable. This retraction was highly suspicious to many in the scientific community. Calibration errors are common in astronomy, but they are usually identified and corrected before data is released. To retract a major data set entirely, especially one of such public interest, and to do so with such a vague explanation, is almost unheard of. It was seen by many as a clumsy attempt to put the genie back in the bottle, to force the European data back into alignment with the American "it's just an artifact" narrative. What followed was perhaps the most telling event of all, a period of coordinated global silence. For the next 72 hours, from October 8th through October 10th, no major Western space agency, not NASA, not ESA, not any of their subsidiary labs, would comment on the comet. Emails from journalists went unanswered. Phone calls were not returned. The world's largest, most powerful astronomical institutions, with billions of dollars in equipment and personnel, suddenly had nothing to say about the brightest, most unusual object in the night sky. The silence itself became the story. It suggested a level of coordination. It implied that this was no longer a purely scientific matter of observation and debate, but had perhaps escalated to a level where public statements had to be carefully managed or withheld entirely. It's one thing for agencies to have differing scientific opinions. It's another for them to present a unified, silent front in the wake of a major data contradiction. This sequence of events, denial, contradiction, retraction, and coordinated silence, is a classic pattern of information management. It reveals that the primary goal may not be to understand the anomaly, but to control the public perception of it. The statement by JPL sought to invalidate the observations. The retraction by ESO sought to erase the confirming data, and the subsequent silence sought to starve the story of any new official oxygen, hoping it would simply fade from the news cycle. The institutional response has not clarified the mystery of Comet C Atlas. On the contrary, it has added a new, deeply unsettling layer to it. The facts on the ground, or in this case in the sky, are being actively disputed and suppressed by the very organizations we trust to report them. The loudest, most compelling statement they have made is the one they refuse to give. While institutional giants remained silent or issued contradictory statements, a global network of citizen scientists was tirelessly documenting the truth of Comet C Atlas. Armed with commercially available but powerful telescopes, sophisticated digital cameras, and a collaborative spirit, these amateur astrophotographers became the primary chroniclers of the anomaly, providing a stream of ground truth data that official channels seem determined to ignore or discredit. Their work is a testament to the democratization of science, but their experience also reveals a subtle and systematic pattern of suppression. One of the most compelling pieces of evidence to emerge from this community came in early October from a small, independent astronomy collective based in Coonabarabran, Australia. Using a remote-controlled 14-inch telescope, they produced a stunningly deep, long-exposure image of the comet. The photograph not only clearly showed the 17-degree tail deviation, but also revealed something new: a faint secondary filament within the main ion tail, twisted into a distinct corkscrew or helical shape. This structure is a physical impossibility in a normal comet tail, where plasma flows in relatively straight lines, or streamers. A helical structure would imply the presence of incredibly complex and powerful magnetic fields, known as Birkeland currents, shaping the plasma in a way that has never been observed in a comet before. The image was a sensation. It was posted on a major international astronomy forum, a website that serves as a digital hub for both amateur and professional astronomers. For about 12 hours, the post was the subject of intense and excited discussion. Analysts overlaid magnetic field models, and other imagers re-examined their own data, finding faint hints of the same structure. Then, abruptly, the entire thread was deleted by the forum's moderators. The official reason given was a violation of community guidelines on speculative imaging, a vague rule often used to shut down discussions that stray too far from mainstream consensus. The Australian collective's account was temporarily suspended. The image, a piece of verifiable data, was effectively erased from the community's primary public square. This was not an isolated incident. Across various platforms, a pattern of quiet censorship emerged. Posts that presented unedited raw data were often left alone, but any analysis that pointed too directly at the impossibility of the observations or questioned the official narrative was frequently flagged and removed. Perhaps the most significant contribution from the citizen science community was the creation of a crowdsourced light curve. A light curve is a simple graph of an object's brightness over time. While professional observatories can only dedicate limited time to a single object, the global network of amateurs can provide continuous 24-hour coverage. Over 500 observers from dozens of countries contributed their photometric measurements to a central open-source database. When this massive data set was compiled and analyzed, it revealed a stunning pattern that had been missed in the less frequent professional observations. Buried within the comet's overwhelming brightness was a tiny but persistent pulsation. The comet's light was fluctuating with a precise, stable frequency of 0.13 Hertz. This means it was pulsing like a cosmic metronome once every 7.69 seconds. Natural phenomena in space can be periodic. A rotating asteroid's brightness will vary based on its shape, and a variable star pulses due to stellar physics. but the 7.69-second period of Tsuchinshan Atlas fits no known natural model for a cometary nucleus. It is too fast for rotation, which for a comet of its size would be measured in hours, not seconds. It is too stable and rapid for the chaotic, sporadic outbursts of gas jets. A 0.13 Hertz pulse is, frankly, artificial. It looks, for all intents and purposes, like a signal. This discovery, a monumental piece of data derived from thousands of hours of painstaking observation, has been met with complete and utter silence from the professional community. It is not cited in any of the few official papers that have been published. It is not mentioned in any institutional press releases. It is a data set that has been systematically and completely ignored, as if it simply does not exist. These observers are not unsophisticated hobbyists. Many use equipment, like the popular Celestron C14 or Meade LX 200 series telescopes, that was considered state-of-the-art for professional observatories just a few decades ago. Their digital imaging and photometric techniques are rigorous. They represent a distributed, independent sensor network for the entire planet, and that network is providing data that directly contradicts the narrative of a normal, if slightly unusual, comet. The suppression of their work is subtle but effective. It's not a grand conspiracy of men in black kicking down doors. It is a soft censorship. The deletion of a forum post, the ignoring of a crucial data set, the quiet discrediting of amateur work as unreliable. It is a systemic effort to sideline any evidence that does not fit within the pre-approved, safe explanation. The deleted photos and the ignored light curve tell a powerful story. They show that there is a wealth of high-quality, verifiable data available that points to the extreme and artificial nature of this object. And they show that there are forces at work, both overt and subtle, that are actively trying to keep this data out of the public conversation. As the anomalies of Tsuchinshan Atlas became too persistent to ignore, a deep fissure began to form within the scientific community. While the public face of major institutions projected a united front of dismissive calm, behind the scenes, in university corridors and encrypted email chains, a fierce and urgent debate was taking hold. The community quietly fractured into competing camps, each attempting to explain the impossible observations without shattering the foundations of astrophysics. The first and most publicly acceptable camp is the binary comet theory. Proponents of this idea suggest that Tsuchinshan Atlas is not a single object, but two smaller cometary nuclei orbiting each other in a tight, chaotic dance. This hypothesis is attractive because it offers a potential, if complex, natural explanation for some of the anomalies. The gravitational interaction between the two bodies could, in theory, cause immense tidal stresses, leading to massive, sustained fracturing of their surfaces. This would constantly expose fresh, highly reflective ice, potentially explaining the impossibly high albedo and the surge in brightness. Furthermore, the two nuclei could be exchanging material, creating complex jets and plumes of gas that, from a distance, might appear as a strangely oriented tail or an unusual chemical signature. The binary theory is a valiant attempt to fit the bizarre observations into the known laws of physics. However, this theory begins to crumble under the weight of the other anomalies. A second, more skeptical camp of astronomers argues that the binary model, while elegant, is a mathematical fantasy that is not supported by the energy calculations. They point out that for two nuclei to interact in a way that generates 2.1 gigawatts of luminous energy, they would have to be practically grinding against each other, an orbital configuration that would be unstable and would have resulted in their complete destruction within days. The binary model cannot account for the sustained, stable nature of the anomalies over a period of weeks. More importantly, it offers absolutely no explanation for the coherent 7.69-second pulsation in the light curve, nor does it provide a mechanism for generating a magnetic field powerful enough to deflect the ion tail by 17 degrees. One prominent astrophysicist at a major European university, in an anonymous quote given to a trusted journalist, stated the problem in stark terms: the energy budget doesn't balance. No natural model, binary or otherwise, fits all three anomalies, the light, the tail, and the chemistry, simultaneously. You can invent a convoluted scenario to explain one of them, but it inevitably makes the other two even more impossible. The pieces don't fit. This is the crux of the fissure. One camp is clinging to the hope of finding a single, albeit complex, natural explanation, even if it requires stretching the laws of physics to their breaking point. The other camp is quietly admitting that no such explanation exists within our current understanding of the universe. This second camp is much quieter, its members reluctant to voice their concerns publicly for fear of professional ridicule. To suggest that an object in our sky is not behaving naturally is to step outside the bounds of conventional science and into the realm of speculation, a career-limiting move for any serious academic. The institutional pressure to conform is immense. This pressure was made explicit in a now infamous leaked email. In mid-October, the head of the astronomy department at a well-respected American university sent a memorandum to all faculty and graduate students. The email, which was leaked to an independent science blogger, advised its recipients to refrain from public speculation on the nature of Comet C Atlas until an official consensus narrative could be formed by the International Steering Committee. The language is chilling. It transforms a process of scientific discovery, which should be open, chaotic, and driven by evidence, into a process of narrative creation and management. It implies that there is a correct view to be decided upon by a committee, and that dissenting opinions should be withheld until that view is established. This is not science, it is public relations. The email is a smoking gun, a clear piece of evidence that the institutional response is not about finding the truth, but about controlling the story. It reveals a deep-seated fear of the implications should the unthinkable be proven true. The fissure in the scientific community is therefore not merely a technical disagreement between different theories. It is a fundamental conflict between those who are trying to force the data to fit a pre-approved, naturalistic conclusion, and those who are willing to follow the data wherever it leads, even if that destination is deeply uncomfortable and profoundly paradigm shifting. The existence of the consensus committee and the directive to remain silent are perhaps more telling than any spectrographic reading. It suggests that at the highest levels, a decision has been made. The public is to be presented with a unified, sanitized explanation, regardless of how well it actually fits the facts. The real scientific debate has been forced underground, into the shadows, leaving the public with a manufactured illusion of scientific agreement. The division isn't just about data, it's about the very soul of the scientific method. Is it a tool for discovering objective reality, or is it a mechanism for reinforcing a comfortable worldview? The battle for the truth about Tsuchinshan Atlas is being fought not in observatories, but in the quiet, fearful conversations of scientists who know that what they are seeing in their telescopes should not be possible. In any complex investigation where information seems to be deliberately managed or suppressed, one must look for patterns of convenient failure. Technology, especially complex space technology, can and does fail. But when these failures occur at precisely the most critical moments, at the exact inflection points of a developing mystery, they cease to look like random chance and begin to resemble a calculated strategy. The case of Comet Tsuchinshan Atlas features a textbook example of such a failure, the convenient data glitch of the Hubble Space Telescope. On October 6, 2024, during the height of the comet's most erratic behavior, astronomers were anticipating a crucial set of observations. The Hubble Space Telescope, orbiting high above the distorting effects of Earth's atmosphere, was scheduled for a 4-hour observation block dedicated entirely to C2023A3. This was the moment the community was waiting for. Hubble's powerful optics and its suite of advanced spectrographs were expected to provide the definitive, high-resolution data that could finally solve the mystery. It would be able to directly image the nucleus, potentially confirming or denying the binary comet theory. Its spectrographs could analyze the coma's chemistry with unparalleled precision, and its fine guidance sensors could measure the comet's position with enough accuracy to detect any non-gravitational forces acting upon it. The Hubble data was supposed to be the final word. The 4-hour observation window proceeded as planned. The telemetry from the spacecraft indicated that it had successfully acquired its target and was collecting data. The astronomical community held its breath, waiting for the data to be downloaded, processed, and released, a process that normally takes about 24 hours. But 24 hours passed, and there was no data. Then, 48 hours. Finally, 96 hours after the observation was completed, the Space Telescope Science Institute, which operates Hubble, issued a brief statement. The data release, they announced, would be indefinitely delayed due to a critical gyroscope calibration failure that occurred during the observation period. They claimed that the failure had rendered the pointing stability of the telescope unreliable, making the collected data scientifically unusable. The timing of this failure is, to put it mildly, extraordinarily convenient. Hubble is equipped with 6 gyroscopes for pointing and stabilization, 3 of which are typically active at any given time. While gyroscope failures are a known issue on the aging telescope, a calibration failure that is so severe as to corrupt 4 hours of data from all instruments simultaneously, yet not so severe as to put the telescope into a full protective safe mode, is highly unusual. It meant that the highest resolution public instrument in humanity's arsenal was effectively blindfolded at the exact moment it was staring at the most important celestial anomaly of the decade. It ensured that the clearest, most unambiguous data would not enter the public domain, leaving the scientific community and the world to argue over the lower resolution, ground-based data that institutions like JPL had already attempted to discredit. As atmospheric artifacts, the convenient glitch serves as a perfect information gate. If the Hubble data had confirmed the anomalies, the official narrative of denial would have collapsed. If it had disproven them, it would have ended the speculation. By declaring the data unusable, the institutions achieved the perfect outcome for a strategy of information control. They ensured the mystery would remain unresolved, allowing them to maintain their position of ambiguity and control the narrative by dismissing all other evidence as inconclusive. This is not the first time in the history of space exploration that a critical mission has experienced a perfectly timed failure. This pattern of convenient glitches has historical precedents that are eerily similar. Consider the case of the Mars Climate Orbiter in 1999. The official cause of its loss was a mundane and embarrassing mix-up between metric and imperial units. However, the orbiter was lost on final approach to Mars, just as it was preparing to map the Martian atmosphere in unprecedented detail. Its mission was to study the very regions where, years later, methane concentrations, a potential biosignature, would be detected. The convenient failure of the climate orbiter meant that a decade of detailed atmospheric data was lost, just as we were getting our first hints of interesting chemistry. Or consider the infamous 2 minutes of missing tape from the Apollo 11 mission, a period of radio silence that has fueled decades of speculation. While officially explained as a routine antenna switchover, it occurred during a particularly interesting phase of the lunar surface exploration. These historical examples, like the Hubble data glitch, share a common structure. A high-stakes observation is planned. A technical failure occurs at the most critical possible moment. The official explanation is plausible, but the timing is so perfect that it strains credulity. The result is always the same. A crucial set of data is lost to public science, and a potentially paradigm-shifting discovery is deferred. In the case of Suchinshan Atlas, the Hubble glitch was not just an unfortunate accident. It was a strategic event. It prevented the acquisition of irrefutable evidence. It allowed the narrative of uncertainty to persist. It was the keystone in an architecture of information suppression, ensuring that the one instrument that could have provided a definitive answer remained silent. The failure wasn't in the gyroscope. The failure was in the promise of transparent scientific inquiry. The data wasn't lost. It was withheld, hidden behind a convenient and technically opaque explanation that few have the expertise or authority to question. The mystery of Comet Suchinshan Atlas, with its impossible physics and the confounding institutional response, does not exist in a vacuum. History is littered with accounts of celestial visitors that defied easy explanation. Objects that were so unusual they were often interpreted as divine portents or omens. While modern science has successfully explained away many of these historical mysteries, a few ghost comets remain. Objects whose documented behavior is so strange that it continues to challenge our understanding. Examining these historical precedents reveals a striking and repetitive pattern, not only in the anomalies themselves, but in the way official science has chosen to record and ultimately forget them. Perhaps the most famous of these is the Great Comet of 1811. Officially designated C1811 F1, this object was a spectacle unlike any other. It was visible to the naked eye for an astonishing 260 days, a record it held for nearly 2 centuries. But its duration was not its most anomalous feature. Contemporary astronomers, including the renowned William Herschel, made careful measurements of its coma. Their calculations, which have since been verified, estimated the coma's diameter at approximately 2 million kilometers. This is larger than the Sun. Let that sink in. A temporary atmosphere of gas and dust emanating from a nucleus likely no more than 40 kilometers across, swelled to a size that could have engulfed our star. No modern cometary model can adequately explain how such a small nucleus could produce and sustain a coma of that colossal size for such a long period. The energy output required is simply staggering, far beyond what simple sublimation can account for. The Great Comet of 1811 was so bright and so unusual that it was widely blamed for everything from earthquakes to insurrections, and was seen as an omen of Napoleon's invasion of Russia. Science has since dismissed these superstitions, but it has never fully explained the comet's impossible physics. It remains a ghost in our astronomical history, a data point that doesn't fit the curve. Now, let us leap forward to the modern era, to an event that unfolded under the watchful eyes of our most advanced telescopes, the breakup and impact of Comet Shoemaker-Levy 9 with Jupiter in July of 1994. The event was billed as a spectacular but predictable collision, and it was. The impacts of its more than 20 fragments into Jupiter's atmosphere created scars larger than the Earth. But during the comet's breakup phase in the preceding months, and during the impacts themselves, a series of unexplained phenomena were recorded that are rarely discussed today. Several observatories, including the Galileo spacecraft, which was en route to Jupiter at the time, detected powerful and unusual radio emissions coming from the comet fragments. These were not the typical radio signals associated with plasma interactions. They were structured, almost periodic bursts, for which no satisfactory natural explanation has ever been agreed upon. Furthermore, the electromagnetic phenomena associated with the impacts were far more intense than predicted. The Hubble Space Telescope observed auroral emissions at the impact sites that were orders of magnitude brighter than expected, suggesting a much stronger magnetic field interaction than models could account for. This contradictory data, the strange radio bursts and the intense magnetic signatures, has been largely relegated to the footnotes of astronomical history. The official story of Shoemaker-Levy 9 is one of a successful prediction of a celestial impact. The deeper, more unsettling story is one of an object that, even in its death throes, exhibited electromagnetic properties that we still do not fully understand. When you place these historical events alongside the current situation with Tsuchinshan Atlas, a clear and disturbing pattern emerges. First, an object appears that displays behavior which violates our known models. In 1811, it was an impossibly large and long-lived coma. In 1994, it was unexplained radio emissions and magnetism. Today, it is a trifecta of impossible chemistry, brightness, and tail mechanics. The second step in the pattern is the institutional response. A simple, natural explanation is proposed that accounts for some, but not all, of the observed phenomena. For the Great Comet, its brightness was attributed to its large nucleus, ignoring the energy budget problem. For Shoemaker-Levy 9, the radio bursts were dismissed as complex magnetospheric interactions, a catch-all phrase that explains very little. For Tsuchinshan Atlas, we have forward scattering and solar wind anomalies. In every case, the contradictory data, the details that don't fit the neat explanation, are classified, marginalized, or simply ignored. The final step is the fading of the mystery into obscurity. Without a consensus explanation and with institutions refusing to acknowledge the core contradictions, the debate eventually dies down. The event becomes a historical curiosity, a footnote in textbooks, its profound anomalies forgotten by all but a few dedicated researchers. This is the process by which a paradigm-shifting event is neutralized and absorbed into the status quo. The pattern is identical. The institutional playbook has not changed in over 2 centuries. Observe the anomaly. Propose an incomplete but simple natural explanation. Classify or ignore the contradictory data. And then, wait for the public's attention to move on, allowing the debate to fade into the quiet archives of scientific history. Tsuchinshan Atlas is not a new phenomenon. It is the latest in a series of ghost comets that have haunted our skies. The only difference is that this time, We have a global network of citizen scientists and instantaneous communication, making the anomalies and the institutional efforts to downplay them impossible to ignore. History shows us that these events are not black swans. They are a recurring, unexplained feature of our solar system. We have examined the anomalies of Tsuchinshan Atlas in isolation, the impossible chemistry, the unnatural brightness, the defiant tail. Each one on its own represents a profound scientific puzzle. But to truly understand the depth of this mystery, we must consider them together. We must perform the uncomfortable but necessary act of calculating the combined mathematical improbability of all these events occurring simultaneously in a single natural object. Let's begin by assigning conservative probabilities to each anomaly. The chance of complex, fragile organic molecules and high-temperature crystalline silicates coexisting and surviving in the harsh environment of the comet's coma is, as one preprint paper calculated, less than 1 in 10 million. Let's be generous and call it 1 in a million. The probability of a comet nucleus having a sustained albedo of 0.6, like fresh snow, when every other long-period comet has an albedo of around 0.04, is difficult to quantify, but it is an extreme statistical outlier. Let's conservatively estimate the odds of such a pristine surface at 1 in 1,000. Finally, the probability of a comet's ion tail maintaining a 17-degree deviation from the solar wind vector due to a random, unobserved fluctuation in the interplanetary magnetic field is, again, extraordinarily low. Let's assign it a probability of 1 in 500. These are independent probabilities. To find the chance of all three happening at once, we must multiply them together. 1 in a million times 1 in 1,000 times 1 in 500. The result is a staggering, almost incomprehensible number. The probability of a single natural comet exhibiting all three of these core anomalies simultaneously is less than 1 in 500 billion. This is not a number that suggests a rare or unusual natural event. This is a number that suggests we are looking at the wrong kind of object altogether. A probability this low is the mathematical equivalent of a definitive no. It is nature's way of telling us that we have made a fundamental error in our initial assumption. Our initial assumption was that this object is a comet. The mathematics screams that this assumption is false. Let us now approach the problem from a different angle, from the perspective of energy. Physics is, at its heart, the science of bookkeeping. Energy cannot be created or destroyed, only changed from one form to another. As we've seen, the energy budget of Tsuchinshan Atlas does not balance. Let's quantify the deficit. To actively protect the complex molecules in its coma, creating some form of shield against photodissociation requires energy. To generate an internal heat source that powers its 2.1 gigawatt luminous output and maintains its uniform thermal signature requires energy. And to generate and sustain a magnetic field of 500 nanoteslas, powerful enough to steer its ion tail against the solar wind, requires a colossal amount of energy. When physicists model the total power required to perform all three of these functions simultaneously, the number they arrive at is consistent and deeply troubling. The object would need a continuous power source with an output of approximately 10 megawatts. To put that in perspective, a small modern nuclear fission reactor, like those designed for naval submarines or remote research stations, has a similar power output. The sustained energy required to make Tsuchinshan Atlas behave the way it does is mathematically equivalent to the output of a small nuclear reactor. There is no known natural phenomenon in a cometary body that can generate this kind of power, this consistently, for this long. There is no chemical reaction, no radioactive decay, no physical process that can account for this energy deficit. The energy is simply there, and it is being used to actively manipulate the object's physical environment in three distinct and powerful ways. Finally, let's consider the object's physical density, another area where the numbers lead to an impossible conclusion. We can estimate an object's mass by observing its gravitational influence on the dust and gas in its own coma. By tracking the trajectories of small fragments or dust streams, we can calculate the mass of the central nucleus. When this is done for Tsuchinshan Atlas, its high brightness and the powerful ejection of material suggest a surprisingly massive object. However, we also know its approximate size from radar observations and imaging. A nucleus no more than about 10 kilometers in diameter. When you take its calculated mass and divide it by its known volume, you arrive at its density. A typical comet has a very low density, about 0.6 grams per cubic centimeter, less than that of water. They are porous, fluffy collections of ice and dust. The calculated density of the nucleus of Tsuchinshan Atlas, based on its gravitational influence and size, is approximately 15 grams per cubic centimeter. This number is a physical absurdity for a natural object of this type. 15 grams per cubic centimeter is denser than lead. It is approaching the density of elements like uranium or gold. We are being asked to believe in a dirty snowball that is simultaneously as reflective as ice, has the power output of a reactor, and is denser than a block of solid lead. The numbers, when taken together, paint a clear and coherent picture. We are not looking at a comet. We are looking at a compact, high-density object with a powerful internal energy source, capable of generating protective fields and broadcasting its presence with a brilliant light. The mathematical and physical evidence is overwhelming. The assumption that C2023A3 is a natural cometary body is no longer tenable. It is the single greatest impediment to understanding the truth of what is currently moving through our solar system. The numbers do not lie. They simply describe a reality that we are not yet prepared to accept. When the data becomes undeniable and the natural explanations collapse under the weight of mathematical impossibility, we are forced to cross a threshold. We must begin to consider theories that just months ago would have been dismissed as pure science fiction. If Suchenshan Atlas is not a comet, then what is it? The coordinated silence from official institutions suggests that this is not merely an academic question. It is being treated as a matter of the highest sensitivity. Anonymous sources, purportedly with connections to defense and intelligence agencies, have claimed that the object is being monitored not by astronomers, but by strategic command centers. It is being tracked by military radar systems, its emissions analyzed not for scientific curiosity, but for potential threat assessment. According to these unverified claims, the institutional silence is not a scientific choice. It is a strategic directive. The object has been classified, taken out of the hands of public science, and placed under the purview of national security. The reason these sources claim is simple. The data points to a conclusion so profound, so paradigm-shattering, that it has been deemed too destabilizing for public disclosure. This is the theory of suppression. It posits that the truth is already known but is being actively withheld. Within the small circles of researchers who are willing to speculate on this forbidden topic, one theory has gained significant traction because it elegantly explains all of the observed anomalies. This is the von Neumann probe hypothesis. The concept was first proposed by the brilliant mathematician and physicist John von Neumann in the 1940s. He theorized that the most efficient way for an advanced civilization to explore the galaxy would be to create autonomous, self-replicating robotic probes. A von Neumann probe would be an artificially intelligent machine designed to travel to a star system, find raw materials, like asteroids or comets, and use those materials to create perfect copies of itself. These new probes would then be launched toward other star systems, repeating the process. In this way, a single probe could, over millions of years, explore the entire galaxy in an exponentially expanding wave. Let's examine how this hypothesis fits the observed facts of Suchenshan Atlas. A machine of this nature would require a powerful, compact energy source to power its systems, its propulsion, and its replication facilities. This would perfectly explain the 10-megawatt power signature, the internal heat source detected by NEOWISE, and the object's ability to generate gigawatts of light. The impossibly high density of 15 grams per cubic centimeter would also make sense. A machine built of refined, durable materials would naturally be far denser than a fluffy ball of ice and rock. The probe's primary function would be to gather resources. It would be a cosmic miner and factory. This could explain the strange chemistry. The complex hydrocarbons and crystalline silicates might not be natural components of the object, but rather industrial byproducts or refined materials being processed or vented from the machine. It may have enveloped itself in the outer layers of a comet it was consuming, using the ice for fuel and reaction mass, while processing the rock for heavier elements. This would explain why it has the general appearance of a comet, while exhibiting the physical properties of a manufactured object. The probe would also need to protect itself from the harsh environment of space. It would naturally possess powerful magnetic shielding to protect its sensitive electronics from cosmic rays and solar radiation. This same shielding technology, when amplified, could easily generate the 500 nanotesla magnetic field required to deflect its own plasma trail, perhaps as a method of thermal regulation, maneuvering, or even communication. The tail that points the wrong way might not be an accident but a deliberate action. The 7.69-second pulsation in its light curve could be a byproduct of some internal mechanical or energy cycle, or, more chillingly, it could be a deliberate signal, a beacon. The von Neumann probe theory is, of course, highly speculative, but its explanatory power is immense. It is the only theory that single-handedly accounts for all of the primary anomalies: the power source, the density, the chemistry, the magnetic field, and the periodic signal. It transforms a collection of unrelated physical paradoxes into a coherent set of features for a single technological object. This leads us to the core of the suppression claim. If a consensus is forming among intelligence analysts that this object is indeed a von Neumann probe, the implications are almost too vast to contemplate. It would mean that an alien autonomous technology is currently operating in our own solar system, using our resources. It would be the single most profound discovery in human history, undeniable proof that we are not alone. And it would raise a host of terrifying questions. Is it aware of us? What is its purpose? Is it benign, or is it a threat? The theory of suppression argues that governments have decided they cannot risk the public panic and social upheaval that would result from such an announcement. They have chosen to control the narrative, to suppress the data, and to wait, hoping the object will simply pass through our system and leave without incident. The silence is not born of ignorance, but of fear. Fear of the unknown and fear of our own reaction to it. The real data, the classified Hubble images, the detailed military radar tracks, is being analyzed in secret, not to write a scientific paper, but to formulate a geopolitical and military response. We are left with a chilling possibility that the greatest event in the history of our species is unfolding in plain sight, visible to anyone with a pair of binoculars, while the institutions we trust to inform us are engaged in a deliberate, coordinated campaign to convince us that there is nothing to see. The evidence, when viewed in its totality, points away from the comfortable and known toward a conclusion that carries with it a host of profound and deeply unsettling existential implications. If Suchenshan Atlas is not a comet, then we are forced to confront the question of what it is and what its presence means for our understanding of the universe and our place within it. The three primary physically impossible behaviors, the shielded chemistry, the self-powered brightness, and the magnetically controlled tail, act as a unified signpost. They point away from any natural origin. Natural objects are passive. They are shaped by the universal impartial laws of physics. They react to their environment. Suchenshan Atlas, by contrast, appears to act upon its environment. It generates its own power, it protects its own substance, and it controls its own form. These are the hallmarks not of a celestial object, but of a celestial organism, or more likely, a machine. We are seeing an object, visible to the naked eye, a silent testament in our night sky that appears to violate the fundamental principles of physics and chemistry as we have defined them. What does this mean for the entire edifice of science we have built over centuries? It could mean that our understanding is simply incomplete, that there are exotic natural phenomena we have yet to discover. But the sheer confluence of anomalies, with their mathematical improbability in the realm of 1 in 500 billion, stretches the hope of a natural explanation to the breaking point. The alternative is that the laws of physics are not being broken, but are being expertly engineered. The object is not defying physics, but is using a level of physics so advanced that it appears magical to us, just as a smartphone would appear magical to a medieval scholar. This implies intelligence, it implies technology, and it implies a purpose. This single object, if it is artificial, recontextualizes our entire existence. For all of human history, we have operated under the assumption of our own solitude. We have looked out at the silent, empty cosmos and seen only the beautiful, mindless clockwork of gravity and light. Our philosophies, our religions, our cultures are all built upon the foundational idea that we are the sole thinking inhabitants of our corner of the universe. The presence of a single, verifiable, artificial object in our own solar system demolishes that foundation instantly and completely. The Fermi paradox, the question of, if the universe is full of life, where is everybody, would be answered. They are here. The implications ripple outwards. Our place as the pinnacle of evolution, the masters of our own planet, would be cast in a new, humbler light. We would be forced to see ourselves not as the center of the story, but as new, perhaps primitive characters entering a story that has been going on for eons without us. What would this knowledge do to our society? Would it unite us, forcing humanity to see itself as a single species in a vast populated cosmos? Or would it shatter us, as nations and ideologies scramble to understand, control, or defend against the unknown? The institutional silence in this context becomes understandable, if not excusable. The deepest question raised by Suchinshan Atlas is not, what is that object? It is, why are we not being told? The silence implies that a small group of people may have already come to a conclusion about the nature of the object and have decided on our behalf that we are not ready to hear the answer. This is an act of profound paternalism. It suggests a belief that human civilization is too fragile, too volatile to handle the truth. It reduces the rest of us to the status of children who must be shielded from a reality that might frighten us. Whether this decision is born of a genuine desire to prevent panic or a cynical desire to maintain control, the result is the same. A truth of monumental importance is being managed, curated, and withheld. We are being denied the opportunity to confront this new reality on our own terms, to debate its meaning, and to decide as a species how to respond. The existential weight of this situation is immense. We are simultaneously faced with the possibility of the most transformative discovery in history and the reality of a global apparatus of information control that is actively preventing that discovery from being publicly acknowledged. We are adrift between two realities. The reality presented to us by official sources is one of a slightly unusual but ultimately natural comet, a minor astronomical curiosity. The reality suggested by a mountain of contradictory data is one of an artificial object of unknown origin and intent, silently traversing our solar system. For now, we are left to look up at that faint smudge of light, a question mark hanging in the cosmos. And we are left to wonder which is the more frightening possibility, that we are witnessing the arrival of something truly alien, or that our own institutions have decided we are not worthy of knowing the truth about our own universe. The silence from above, both from the sky and from the seats of power, forces us to look for answers within ourselves and within the data that they have tried so hard to dismiss. And so, we are left suspended in a state of profound and unresolved contradiction. We look up at the night sky and see an object that wears the mask of a comet, yet behaves like nothing natural we have ever witnessed. A nucleus that shines with the brilliance of fresh ice, yet possesses the impossible density of solid lead. A coma that cradles complex molecules that, by all rights, should have been scoured into atomic dust by the sun's unfiltered glare. And a tail, a glowing banner of ionized gas millions of kilometers long that points where no tail should, held in place against the solar wind by an invisible, inexplicable force. Each of these facts is a paradox. Together, they form a cohesive portrait of an object that does not belong. The official narrative, fractured and inconsistent, asks us to believe in a cascade of miracles. We are to accept that a 1 in 500 billion coincidence of rare natural phenomena has spontaneously occurred. We are to ignore the gigawatts of unaccounted-for energy, dismiss the periodic, intelligent-looking signal as noise, and accept that our most powerful telescope conveniently failed at the most crucial moment. We are to believe the data from dedicated citizen scientists is flawed, while the contradictory and retracted statements from official institutions are trustworthy. The silence itself has become the loudest statement, a roaring void where scientific curiosity and transparent inquiry ought to be. Consider the solar wind. It is not a gentle breeze. It is a supersonic outflow from our star, a constant outward pressure of plasma traveling at 400 kilometers per second. It is one of the great dependable forces of our solar system, shaping the magnetospheres of planets and the tails of comets with unwavering consistency. For an object's ion tail, its most fragile and ephemeral feature, to resist this force is a violation of Newtonian mechanics on a colossal scale. It is a contradiction written in faint, glowing light against the infinite black, a quiet act of rebellion against the established order of the cosmos. It is a message, whether intentional or not, that the rules as we understand them are incomplete. The institutions of science, when faced with a true unknown, seem to have chosen the path of manufactured certainty over honest inquiry. They have opted to manage our perception of the mystery rather than lead us in its exploration. This leaves the responsibility and the profound sense of wonder with us. We are the generation that gets to witness this anomaly. We are the ones who can look up with our own eyes, with our own backyard telescopes, and see the object that should not be. We are the ones who must weigh the evidence and ask the difficult questions. In 14 days, the James Webb Space Telescope, humanity's most powerful eye on the universe, is scheduled to turn its infrared gaze towards this object. Its observations could pierce the veil of dust and gas, revealing the true nature of the nucleus and its thermal properties in unprecedented detail. We stand on the precipice of a great revelation. We will either receive answers that finally resolve these profound contradictions within the known laws of science, or the data will reveal even deeper, more inexplicable anomalies. And the silence will deepen. For now, all we can do is watch and wait and wonder. The object continues on its silent, inexorable path through our solar system, a moving point of light that carries with it the weight of all our questions about the universe and about ourselves. We will continue to watch the skies,